Hi everyone. For this lesson I want to demonstrate how we use our calculator to find the equation of a polynomial that will pass through the three given points. So this is one of the questions on our review worksheet, and the question says TEC active. We're expected to use our calculator. I know you can solve this manually, but it's a lot faster with the calculator. Certainly on an exam, if it's a TEC active question, you use the calculator to save time. So first thing we want to do is go to the statistics app here. Then in list 1 and list 2, I've entered the coordinates of my points. So 0, 10, all the x coordinates are in list 1, all the y coordinates are in list 2. So I've made a note here. Remember, the examiner can't see what you've done on the calculator, they can only see what you've left written on the page. So make a note that you were using your CG50 and you were in the statistics app. Make a note that you entered the data in list 1 and 2. Now, when you hit F1 here for graph, there are 3 different statistic graphs available. And there's many different types of statistic graphs. Always check the settings first. Now, for the first graph, it is a scatter chart using list 1 for x and list 2 for y. That's how we want it. And with frequency 1, which means every data point appears just once. That's exactly how I want it. I could, of course, hit graph 2 to find out what it was about, and graph 3. So graph 2 and 3 are different graphs. And if, for instance, I just look at the options, I can have line graphs or pie graphs or other weird things. I don't want that. So graph number 1 is the one that was all set up properly. Remember, graph 1, scatter chart, list 1 for x, list 2 for y. So hit exit to get out of that menu, and now we'll literally just hit graph 1, and we can see the data points plotted there as if I had just plotted them on my page. Now calculate. Then I want to use x squared. I think it's a second degree polynomial. If there's 3 data points, I can definitely fit a second degree polynomial. So I hit that. Here is my value of a, b, and c in the standard form of the quadratic equation. So I've written this down. I did graph 1, I did calculate, and I chose x squared for the model. And here it is, negative 1 times x squared minus 3 times x plus 10. There's my formula. If I draw that, you can see that it goes beautifully through the points. Okay, that's all for this time. Thanks for watching.